Welcome to my talk. I'm Jacek Laskowski, and I'm speaking now about, I'm speaking during this session about Spark SQL and internals of structured query execution. So I'm using this English term to refer to the different stages our queries will go through whenever we execute anything on Spark SQL or using Spark SQL. At the same time, structured query or query execution to be exact, is the name of the class of this Scala class that lives beyond this structured query execution. So whenever I say query execution, I may mean two things. One, this Scala class called query execution. Second, query execution in this general, how to say, meaning, okay, common meaning. So just be careful, okay? And I should be careful too. So just before my talk, I'm gonna take a selfie with you guys. So yeah, I'm learning this. Oh, okay. Oh, it's gonna be like this. Okay, so you know this trick, right? No, don't do this. Okay, so in Samsung devices, you can just say hi to your device, and it will recognize that you want to take a selfie. Did you know it? No? Okay, just say hello to your mobile. It only works on Samsung. I'm not sure if it's something Samsung related or if it's Android or whatever. Anyway, it works on Samsung 7 Edge. Okay, good. So internals of, and by the way, I'll take another one, much better one, with you guys. Okay, so say hello to my Twitter stream. Hello! Good, thank you. Okay, so internals of structured query execution. We are speaking about Apache Spark 2.3. This is the latest and greatest of Apache Spark. And when I say Apache Spark, I really mean Spark SQL, okay? We are not here to learn the foundation of of Apache Spark. I am not gonna mention RDDs. Well, I'm gonna do this twice. I did it once, so I'm gonna do this another, second time in a moment. But this is just these two moments in your life when you should hear this name, okay? My take on this is stay away from this and only use data frames and data sets. Why? You should ask questions about why, and so I can answer this question. This is not a talk about why this or that. It's about internals of structured query execution. But just, heads up. Okay, so my name is Jacek Laskowski. I'm an independent consultant working exclusively with Apache Spark and also with Kafka, Kafka Streams, and Scala. My favorite programming language is Scala because, as you know, Apache Spark and Kafka Streams are both just frameworks, programming frameworks. You need a programming language, so out of 4, or some may say 5 different programming languages supported by Apache Spark, I chose Scala, okay? For various reasons. This is not the topic of this talk. And so I'm offering development consulting and training services. I try to be quite active in Spark community because, by the way, I'm paid for being active and know enough so I can get paid, right? Because I'm independent consultant. So follow me on Twitter at Jacek Laskowski just to master Apache Spark. I'm tweeting like crazy and mostly about Apache Spark. I very rarely speak about anything but Apache Spark, okay? So I'm best known by a couple of Git books. They are free of charge. You don't have to pay for it. I am working on a book that you will have to pay for. By the way, it was written by 2 French people, if I'm not mistaken. It's Spark in Action, so I'm working on 2nd edition. It's not official, so this is please cut it out of this recording. So best known by this Git books. I've got 5 Git books. Yeah, because I've got lots to say. And among them is Mastering Apache Spark and Mastering Spark SQL. This one got pretty famous, and this one is catching up, okay? But this is this is primarily only exclusively about Spark SQL. You can find this is pretty much like you would be looking at the source code, but using English words. Okay, so if you don't like Scala or you don't want to spend much time on Scala, but you know enough Polish English, you can just understand mastering Spark SQL pretty easily. Okay, I'm also quite active on Stack Overflow. Just before my talk, I fixed one title of a person who asked a question about Apache Spark. So I'm helping people because, by the way, I'm helping myself too. By thinking like others about Apache Spark, I can get better, right? I can talk to you, your words, using your words, your language. No, I'm not speaking about French. I'm going to use your way of thinking about Apache Spark to explain my way, my way how to look at Apache Spark. And that's what I'm going to do today. So, agenda. We've got 45 minutes minus 10 minutes for questions. And I would appreciate if you could ask questions as we go through this topic. So please raise your hand and let me know that you've got your question. So this is our agenda, and these are 7 main topics, and they've got some subtopics. So we've got pretty much around 20 slides and some code, some interactive sessions. So yeah, it's pretty heavy. I hope so. So what's structured query? So whenever I say structured query, I mean query just like written in SQL or Scala or Python or R. I don't care what programming language or meta-programming language, speaking about SQL, you use in Apache Spark. This is a query, description of a query. Why is it structured? Because you need to know, or Spark needs to know enough about types and whether these types accept nulls or not. Why? Because we are speaking about big data, and big data is about big data. Whatever, regardless of the definition of big data, it's pretty huge, and it's more than your one single computer can handle. So the better Spark can handle your big data, the better for your queries, right? And just to cut the cost of hardware you need for processing big data. So the structured queries are the bread and butter of Spark SQL. Everything in Spark SQL is about executing these structured queries. Okay, so why is structure important? Because we need to think about space to hold all the data we are processing using Apache Spark. There is this Tungsten project we will mention. We'll be speaking about this, or I'll be speaking about this Tungsten project at the very end, but this is just about how to lay out data in memory and on disk. And this is just, some side information. It's not the main topic of my talk. So, query languages in Spark SQL. In Spark SQL, you've got 4 programming languages supported. Among them are Scala, or they are Scala, Java, Python, and R. And some people, include SQL as a programming language. I don't mind. As a matter of fact, after 40 years, yeah, I'm 40 now. So after 40 years, I understood that SQL is pretty powerful language. You can express pretty complex structured queries or queries using few words. Compare it to Scala or Java, Python, and R, and you will know what I'm talking about. So I was 10 years ago, I thought that SQL is for people who are who should forget about doing anything in IT because SQL is a crappy language. But now I stand corrected. SQL is pretty powerful. Might be that I got older, and that's why I'm like this. So Spark supports SQL, good old SQL 92. There are some extensions like SQL 2003, and some other extensions like TSQL. So windowing is supported. Functions like give me rows before or after this current row. Yeah, these things are supported. Pretty much everything you learned about SQL is supported in Spark SQL. And why am I focusing on SQL for so long? Because it doesn't really matter whether you are using SQL or Java or Scala. That's true for Scala versus SQL, not sure about Java. So it doesn't really matter, because eventually you will end up with something which is the main topic of my talk, query execution. So SQL, good old SQL, SQL 92, HiveQL is supported too. Why is Hive important for Spark SQL? Because many enterprises spend enough time, or they spend enough money on introducing Hive to their architectures. Now we Spark people consider Hive obsolete. So the better Spark support for Hive, the better for our migration projects. So pretty much everything that you can find in HiveQL is supported by Spark. I say pretty much because I know almost nothing about HiveQL. So yeah, I just allow myself for saying something that leaves some room, for things that are not supported by Spark SQL. Grammar SQL is described in Spark SQL by this grammar. They use ANT-LR. This is the language that you can find, that the grammar describes every SQL that's supported by Spark SQL. So you can find this G4 file in the official repository of Apache Spark, and you can find every query that's supported by Spark SQL. Pretty much, because there might be some edge cases that are not supported. Okay, and data frames, there is this discussion about what's the difference between this three-letter acronym starting from O, ending with D in the middle, data frames and data sets. So there are a few differences, and even even between data frames and data sets, you can find differences that have impact on performance of your queries. But just so we are on the same page, data frame, collection of rows with a schema, okay? There is this notion of row and row encoder, because eventually this tungsten sub-project needs to know how to layout your data. So, but as of Spark 2.0, now we've got Spark 2.3, data frame is nothing else but data set of rows, okay? So it's just type alias in Scala for something, described by this generic data set type with this concrete row type. It's just to know how to deal with data, okay? So data sets, it's just, a general concept in Spark to hold data of any size and shape, okay? So this is just the most generic way to describe data in Spark. But we're just digressing. So, Project Catalyst. Now we are finally closer to C query execution. Definitely, we are going lower and lower. So definitely, if you are wondering if we are discussing internals of Spark SQL execution, yes, we are. Or in my definition, yes, we are. So Project Catalyst, you may have heard about Tungsten during this talk and before, and as well as about Project Catalyst. Project Catalyst is to allow for processing trees, and that's it. So this is tree manipulation framework, okay? So whenever you hear Catalyst in Spark or Spark SQL, think about trees. Not these trees, on the street or, in a forest, just trees. Algebraic data structures, they are recursive. So node can have subnodes, children, that can have, other nodes. And having this, you build this, this data structure called tree, okay? So Catalyst is nothing else but, hey, I'm giving you tools to manipulate trees, okay? Why is it important? Because everything in Spark SQL ends up as a tree, in a way, okay? In a way. So we've got tree node. This is a type in Scala with child nodes called children, and this children method gives, subnodes. So this is recursive data structure, and you've got rules to manipulate trees, okay? Think of it. You've got trees of something and rules to manipulate trees. So you've got enough tools to create tree node, yeah, this is the basic, and query plans, which are coming, okay? So tree node is just a node with children, and you can see the source code of tree node out of, as of Spark 2.3. So when you look at tree node source code, you will see this weird syntax for generic type. This is type constructor, tree node. So think of it, if you are not familiar with Scala, think of it as a function that gives types, okay? So out of this generic type, you can build other types, you will see in a moment. It's an abstract class, so for people familiar with Java, it should be familiar. So tree node, there are different tree nodes, but the point is that you've got children that it's just a sequence of these tree nodes that can have other tree nodes. Very good. So out of these tree nodes, you've got query plans or query plan here, and then concrete query plans are Spark plan and logical plan. And that sounds like a database thing, right? So we are closer and closer to see query execution and expressions. It's been a while since I considered tree node and query plans the only ingredients of any structured query. And I was surprised to find that expressions are also crucial for our for our queries. You will see it in a moment, but just think about it. Think about it. You've got query plans that are made up of nodes with expressions, okay? So that's why it's hard to explain query execution using two names like tree and node. Knowing that a node can be a tree too, it's kind of confusing often. Anyway, so query plans. Now we are going lower and lower in this tree hierarchy or type hierarchy. So now we are at this query plan level. So query plan is nothing else like a description of any query you can write in Spark SQL, okay? So of course, this is just abstract class, so you cannot instantiate query plan. You can just create Spark plan or logical plan. And as you will see in a moment, Spark plan is physical representation of your query. After you create a query, you create something that's called logical plan. And there are three different logical plans. So you've got query plan, the base node. Again, this is node, but it can also be a tree because node can have children. So this is the base node or foundation for relational operators. And knowing that operators are nodes that can have children, they are trees. So relational operators, what can they be? Well, select, projection, filtering, join, what else? There are some others. You've got logical plan, and logical plan is the internal representation of any structured query you write. So whenever, regardless of the programming language or language to describe your query, SQL, Scala, Java, Python, or R, you will always end up with logical plan, always. It's called unanalyzed logical plan, but this is a logical plan. Eventually, after all this query execution, you will end up with one single Spark plan. And this is pretty much query execution pipeline. So, catalyst expression, the last but not least, expressions, the ingredient I forgot to mention for a couple of years while I was describing Spark SQL. So expression is just an executable node in this catalyst tree made up of operators. So operator is just join, okay? How many children can a join have? 2, left and right, correct? Because any join you can think of has to have two sub-operators. But these operators are like, let's say, selections. You are projecting your table into smaller number of columns. By using select, you are specifying, hey, give me column first and second. These are expressions. So just rather than waving my hands, let me show you this using Spark Shell. So this is Spark Shell. This is nothing else but Scala REPL plus some imports preloaded for you. So there are some implicits, there are some imports. So all these make your life in Spark Shell much easier, okay? So, and by the way, in Spark 2.3, if I'm not mistaken, they added Spark SQL, so you don't have to import it yourself. You can just type show tables. Good. So I've got one table registered, okay? And as you can see, I executed this SQL show tables here, and I pre-configured this table, okay? Just for fun. So can I execute this query using Scala? Well, I did it in Scala, but this is pretty much a mixture of Scala and SQL. So let's do this the other way. Spark, catalog, and list tables. And show. So I've got another information about my default table. These are extra information. I can get this information using the other way. But the point is that regardless of the language, I am creating something that's called data frame. Correct? Also, Spark catalog. Okay, let me bring it up. Type. Here, I've got dataset. But as I said, it doesn't really matter whether you are doing data frame or dataset or Scala, Java, SQL, Python, R. It doesn't really matter because under the covers, they are using something like this. Explain will give you plans. By default, this explain, just like in SQL, will give you executable plan, okay? Physical plan. If, however, you use this extended version, so I'm using this named parameters, you will get all 4 plans, okay? Out of them, 3 are logical, while this one is physical, okay? Any query you write using Spark SQL will look like this. Any, okay? Unless it's not a structured query, okay? So going back to, and speaking about expressions, because that was the moment where I switched to this Spark Shell, let me write this. Select, I'm not sure if table name is something like this. Hello. Okay, so there is no table name. So how can I know about the shape of my query or all the expressions I can write? Well, I can do this. So let me type it as a query and Q print schema. So I now know that rather than using table name, I should be using just name. Ta-da! There is no select. I just did select. I should have done filter. Ta-da! No tables like this. Okay. And the reason I did it was that I wanted to show you that this one is nothing else like a column expression that has reference to this internal expression, catalyst expression. You don't believe me, right? And you should not. So this is a column. So let me create a column. So I've got this C, and I can use it rather than using this verbose way I can do C. Yeah, it works, okay? I just, change I just introduce one value. But the point is that this C, the type of this C is a column, and ask for expression that lives beyond or behind this column shell. So how to do it? Expression. Now you are at the expression level. And you can, and hey, you don't have to know Scala, Java, Python, R, or SQL to write this. You can just use these ingredients, query plans or expressions and operators. Okay? So as you can see, there are other languages supported by Spark SQL to create queries, in a sense. Okay, going back. Are there any questions about this? Is it good enough, or you got bored already? Okay. If you got bored, let me know, okay? I don't want to lose you just, 10 minutes after I started my talk. Okay, so I've got some crazy stuff, lurking in my slides, so don't worry about it. So this is expression, okay? And think about expression as a code that will execute a value per input row. Because after all, Spark SQL is nothing else like executing code that will get applied to your data, and for any row in your data, for any record in your data, this query will produce another value, okay? Whether it's a simple select, filter, or grouping, you will eventually produce values out of input rows, okay? Internal rows, to be exact. So, okay, so this is just eval. This is the method that expressions use under the covers. Rule. So we have these ingredients: query plans, which are trees, and we've got expressions, which are also trees. And we know that Catalyst not only gave us these ingredients, but also rules. And since we have rules to process these trees, we also need something that's called rule executor. We will get to it. So rule is just a very basic class, as you can see, with two values or two methods. One value called rule name, just so you can reference rules by names, as well as this method apply. And in Scala, as you know, apply gives you this nice syntax, so you can execute a rule without specifying name of the method, correct? So this apply is used to apply rule to a tree type. What tree type could you think of? Well, logical or physical plans, expressions. So I gave you 3 different tree types, but you can think of 5 or even 10. Okay, you can create your own if you want. Catalyst is generic enough to take any tree type that's subtype of tree node. Very good. So and last but not least, in this Catalyst framework, we've got rule executor. Rule executor does nothing but executes batches of rules that we saw previously. So you can create any rules you want, but you can also expect that Spark SQL comes with preloaded rules, so you can just execute your queries. And yes, there are rules. There are at least, well, not at least, there are about 50 rules, different rules, that optimize your queries, so eventually you get the benefit from Spark SQL, or using Spark SQL, or applying Spark SQL to your data. So just think about this rule executor. Again, it works with tree type. There are 3 main tree types: logical, Spark plan, logical plan, plan, Spark plan, and executor and expressions. And think about batches that transform from one shape to another. So rule executor is nothing else like a function that accepts a tree and gives you a tree. So when you think about it, you get all the optimizations, all the analysis that happens behind the scenes whenever you execute query. Finally, we reach to this point where I can say query execution. So all these ingredients that I introduced before were just to introduce query execution. Query execution is behind any query you write in Spark SQL. Whenever you write your query, whether it's SQL, Scala, Java, you will create query execution with all the trees that are needed for your query to be executed. Okay, so query execution is the heart of any structured query. You use, as we did, explain to know your the different plans. There are more, but there are 4 official plans out of 7 or 8 you can see, or you can just use query execution directly and just query for all the different queries that are available for your single query written in SQL or Python, whatever. Okay. Eventually, this is the moment where I'm gonna mention it. Eventually, you will have to create this 3-letter acronym starting with R, because I've got only 1 slot to use this name, so I'm not gonna use it now. I'm gonna use it in a moment. So after you do this 3-letter acronym, you will get your lovely 3-letter acronym, starting with R, ending with D in the middle. Okay? So think of it. If eventually you will create, okay, pardon me, I'm gonna use this RDD again and again. Okay? So after you do RDD, you will end up with RDD because Spark can only execute RDDs. So guys, what's Spark SQL then? If Spark can only execute RDDs, so what's the fuss about the structured queries? What about them? In other words, how can you define Spark SQL for people knowing all this I shared with you, for the past 10, 15 minutes? Spark SQL is nothing else but just different way to create RDD-based calculation. It's just different way. And knowing that you can use Scala, Python, or SQL to generate your Spark SQL queries that eventually end up as RDDs, you see, so there is one function, another function, and at the end, we get these good old RDDs. That's the beauty of Spark SQL. It's just a wrapper around RDD, so you don't have to spend much time on it, because you don't have time for this. You don't have to learn all these optimizations that are available in Spark SQL out of the box for free, because Spark SQL is open source project, so you can just use it without thinking about this relational algebra, all these optimizations that you can expect from databases. And this is the moment where I ask this question during my courses or trainings or meetups. What's the difference? What's the definition of database? And when you think about it, and my definition is like this. There are 2 ingredients or 2 parts in any database. And I'm not speaking about relational database or non-relational database, any database. So my definition would be like this. A database is something made up of 2 things. 1, query execution engine. 2, storage. Is it okay? So for me, it's okay. Probably database purists, we've got people from DataStax, they might get offended or they might not accept this definition. For me, it works. So what's missing in Spark SQL to call it a database? Storage, which for Spark is HDFS in most cases, okay? In many cases, not most. Anyway, I just digressed. So we are digressing. So query execution pipeline, finally, think about trees and rules that are part of Spark SQL that eventually will produce 10 minutes, 5 minutes, or 10 minutes? 10 off. So we've got SQL that eventually will become a data set. And whether you are using Scala, Java, Python, or R, or SQL, you end up here, okay? Then, when you trigger an action, let's say show, you are here. So what about all these boxes? Well, this is what you call Spark SQL. This is exactly why you like, love, or hate Spark SQL for. Okay? So there are 6 stages. I call them pipelines, transformations, whatever, okay? So you've got unresolved logical plan after you create your data set. Then, after analyzer process this unresolved logical plan, you get analyzed logical plan. By analyzing your query plan, you are sure that your tables and all the columns are resolvable, they are available, and they have types, okay? So at this point, you know that tables and columns made out of these tables or references to columns, they are resolvable. Then you can expect some performance optimization at this point where all the cached data sets are replaced with the cached versions. So if you are using 2 same queries, one is cached, another is not cached, Spark SQL will replace these 2 entries with cached version, which is cool, right? So this is with cached data. Then optimizer kicks in, Spark logical optimizer, this is logical optimizer, and creates something that's called optimized logical plan, okay? It's available using optimized plan value out of query execution for a dataset. So all these names are names of values or methods that generate values, lazy values that are available on any query execution object, which you create by using Dataset API or SQL. Eventually, after these logical transformations, you expect something physical, something executable. This is where Planner kicks in and creates at least one executable query plan or physical query plan. I said at least one because there is this code available in Spark SQL, which Spark SQL doesn't use, by the way, for creating multiple physical plans. Why is it needed? Because having multiple different physical plans, you can just choose the best one for your use case. So here in Spark SQL 2.3, just one physical plan is generated. It could be that you can create Planner that will offer more, but it's not available out of the box, okay? So having physical plan, there is another optimization here that will optimize this physical plan into real executable physical plan. And out of this executable physical plan, you get this lovely RDD by using 2RDD. Anything you will execute in Spark SQL will end up as a RDD. So Spark Analyzer, just a code that validates that your tables, your references to columns and the types are correct, okay? That you can do plus on numbers rather than plus on something that does not define plus, okay? Then you've got Spark Optimizer. By the way, the slides are going to be available, and they are available on my GitHub account, so don't worry. You don't have to take much notes other than something I say. It's not included on the slides. So Spark Optimizer, another processor that's available in Spark SQL. And you've got Spark Planner, and eventually, this is, by the way, this is the moment where you can leverage cost-based optimization. So cost-based optimization happens at planning stage, okay? So this is something before you get final physical plan. And eventually, you will get something I call, there is no official name for this in the code. There is no class behind it other than preparations method that will be something I call Spark Physical Optimizer, okay? So there are preparation rules for whole stage code generation under the covers of any query, there is Java code, not Scala, not Python, not R, Java. Then there is this optimization for raising exchanges, which are shuffles, so you don't have to do many shuffles, and subqueries, because you can refer to different subqueries, but they eventually create something that you can reuse. And look at this. This is the type of this object, of this method, is sequence of rules of Spark plan. And we know that rule of Spark plan is nothing else like transformation of a Spark plan to create a Spark plan. So now you've got these different Python-specific rule for processing Python code, plan subqueries to trigger subqueries, ensure requirements for different partitioning and distribution schemes, collapse code gen stages for generating Java code, reuse exchange, and reuse subquery. These are physical optimizations available. So finally, we are discussing RDDs. And you know that behind the scenes, Spark SQL will create, and by the way, this 5 minutes before my talk finishes, is it with a Q&A or without? With. Yeah. OK, so let's keep it. So, and RDD lineage. So I'm going to show you something that you can use right away while working with Spark shell. So let's create a query, OK? Spark range 5 show. Very basic query, OK? OK, you are more for, so create or replace temp view. So Paris. OK, so now you can do something like this. Select star from Paris. Ta-da! Same, OK? I just made this query. I just alias it as a table, OK? So now you are looking at SQL. So, but, it's nothing else like query, correct? Correct. So, and query in Spark SQL is nothing else but data set or data frame. It doesn't really matter. For our discussion, it doesn't really matter. But under every query, any query, you can ask for something that's called query execution. So QE, it's a shortcut for tab. You get this query execution. Ta-da! You've got query execution. By default, toString will give you this, this explain-like output. But you are not interested in query execution just by definition. You want to see all this, correct? Let me show you this. Let me see analyzed, OK? So query execution dot analyzed. Ta-da! Analyzed logical plan. Then you are interested with cache data. OK, let's do this. With cache data. Ta-da! You are interested in optimized plan. OP. Ta-da! So doing this, you can interact with this low-level, internals of Spark SQL execution. Any query ends up as this, OK? And if you get bored, you can just do explain, and then you can just extend that through and see all the main stages of any query execution. And I could introduce you to more, but as you can, no, we are just, and by the way, I mentioned something. I've got 2 more slides, but they are not very important. You've got enough knowledge just to leave this class thinking that you know what Spark SQL can offer for you. And you'd be right, by the way. So I said that eventually you will get RDD, right? Right. And you want to see RDD. And you want to see the Java code that generated for your query, right? Who is to see Java code behind any query? Raise your hand. Yeah, OK, good. So we've got this query, correct? So this is our data frame. Any data frame is a structured query. It's a synonym, OK? So now Q, and then you can QE. So you are very low level. And then you can, hey, give me this little object that holds all the Java code that generated for my query and show it. So code gen. And look at this. For my query, for my simple query, Spark SQL generated this code. This is the code that's executed for my simple query. It's written in Java because Java is well optimized on JVM, which makes sense. So they created this Java-based code for your query. Most of your queries will end up like this, okay? Most, because there are some, differences. There are some codes that won't end up as a subtree with Java code, but there are very rare situations. And the last but not least, this is the Java code, and I said something about RDD. Remember, you wanted to see RDD, right? So, what's the method to get this RDD out of my query? To RDD, right. So I've got my RDD of internal rows. You could also have created this query yourself based on RDD API. Yep, and the last one is debug string. And you know what's debug string? It's nothing else like just lineage of your RDD execution. And eventually, you want to, for each unit, so you executed it, and you want to see it in here, and you can use SQL, but you can also see jobs for my for each here. So depending on the API, you can get different performance, okay? Your performance or query performance. So stick to Spark SQL as long as you can, unless you know the reasons for going down to the bottom and use RDD directly, okay? So that was the message I wanted to, plant or, in your minds after my talk. So know that Spark SQL is just nothing else like RDD-based code generator with some Java code generation, and that's pretty much it. So all you can execute on Spark has to be RDD-based. And that's it from me for today. If you've got any questions, let me know. Thank you. May I have one question to my audience? Okay, so do you have any questions? Just one or perhaps two questions? Do you have any questions? Come on, don't be shy. Yeah, thank you. Say your name, okay? Before you start your questions, I can refer to you, not you, just by name.
Okay, Leonardo here. Many thanks for your talk.
Okay, Ian.
Okay. Just to be a question about the code generation.
Yes, code generation.
Which piece of code is generating the code? Is Tungsten project behind?
Sorry?
Which piece of code is generating the code?
What part of Spark SQL generates this code?
Yeah.
Okay, so there is this special code. I can refer. I can show you after my presentation. That's responsible for going through all the whole stage exec operators, and they know how to generate Java code. Every operator, every physical operator knows whether it supports code gen or not. If it supports code gen, it knows what Java code to output whenever asked for produce path or consume path, because there are two paths to generate code for. One is to consume rows, other is to produce rows. Okay? Consuming is as an input, generating or producing is whenever this output produces rows.
Okay. Okay.
So you should be looking at physical operators specifically to know what code is generated for this particular physical operator.
Okay, good, thanks.
Welcome. Any other question? The last one?
Hello, Jean from Influence.
Jean.
Thanks for the talk. I want to ask if there is a limit to the size of the logical plan or physical plan. Should we avoid having very large plans by structuring our code differently?
So the question was about size of our structured queries. So yes, there is a limit on how big our queries can be. Why? Eventually, we need to generate Java code. And we know that JVM has this limit of 64 kilobytes for our methods or classes? Classes. I know that there is a limit on how big our method can be, as well as how large our classes can be. So there is optimization that can cut, the size of our classes, but you need to be very careful. So you can see problems with, generating too large Java code, even though you are not using Java for your queries. So this is because from, behind the scenes, you will trigger this code generation, and if this code generation creates more than 64K code, you will get this error message. So yes, you need to be very careful. And by the way, my last tweet was about something that I thought is true, but after months of exploring Spark, I realized I was mistaken. So please take all my tweets with a grain of salt, because sometimes I'm so sure about things, after a moment I am not. So the point was, I said something like this: why don't we create super crazy complex queries so all these reuse subqueries can kick in and optimize our queries? I was mistaken, because first, I'm limited by the size of my method that will get generated. And even if it was not a problem, there is this subquery execution that happens on a thread pool, which is exactly as if I called this query before executing this, main super heavy query. So no, I was mistaken, but it's pretty much what you asked for.
Thank you.
Welcome. That was the last question, or one more?
One more.
Yeah, one more. No questions? Come on. Oh, thank you. 3 questions. So this is my, my personal score record.
Hello, I'm Pierre for Air France. I wanted to ask you, in which do you have examples where we would want to use RDDs to do optimization? Are there generic examples you can cite? Or?
Was your question, let me rephrase your question so I'm on the same page. Did you ask about whether, or when should I be using RDD API versus data frame, hoping that my query gets better? Was this your question?
In which do you have an example of cases where one would want to use exclusively RDDs?
Okay, so I'd say there are no use cases where you could use RDDs. If you can find cases where RDD-based query is better than data frame query, it's just exception that should be, should be fixed in the upcoming version. This is just official answer. But yes, there are some cases. I read some articles about, I call them weird, not necessarily structured processing, like images or, something unstructured, where structured processing does not make much sense. So whenever we speak about something that can get structure, have structure, I doubt you can beat performance of structured-based or data frame-based queries with RDD-based API. It will take more time at execution or at write time, design time. That's all from me. Thank you for your questions. I'll be around, so if you've got any questions, let me know.